Hey guys, this is Connor Harrigan, and today I'm going to give a short presentation about my project Batility and what it can be used for. So as I said, my project is called Batility. It's an Android utility app which will gather important battery data for the user, which will hopefully allow them to make better educated decisions about what types of cables they should use and potentially why their battery is getting drained. The main reason why I wanted to do this project is because I'm interested in current battery technologies and the limitations that are involved. So one of the biggest complaints that you hear from people about their smartphones is that they're only able to hold enough charge for a single day, and then sometimes people have problems where they run out before the end of the day. This app won't magically reduce battery usage, but the ultimate goal of this project is to help people make more informed decisions about what cables or chargers to use based on what charging levels they see. The second reason I decided to do this project is because I've wanted to learn how to develop Android apps for a while now, because it seems like a valuable skill to have, especially considering how many Android devices are available on the market and considering how many companies are developing apps for their employees to use in a business setting. So during my project, I've had to keep checking to make sure that what my project is going to do is feasible, and I've done so through several different methods. First off, I've had to make sure that the programming will work on Android devices, and to do this, I've just made a couple quick applications to make sure that I could gather the correct variables and then output them to the screen or to the user. The second part that I've done is I've started to test out my application on several of my friends and family's devices. So I've used my own. I have a OnePlus One. My brother has an LG G Flex 2, and then I have a friend with a Nexus 6. And so far, all three devices have worked, which is great news. And lastly, to make sure that this project is feasible, I've made a timeline just to make sure that I stay on pace. And a few of the milestones are listed down below. So by March 10th, I hope to have finished the initial testing and compatibility to make sure that so that this app will work on all devices. By March 24th, I hope to have an options menu and the cable quality done. And by the cable quality, I mean the app will be able to tell the user in real time what quality of cable is being used. So whether it's poor, average, or good quality. By April 7th, I want to have the ability for the user to save the cable's data and then access that data at a later time to be used to compare against different cables so that they can compare cables. By April 17th, I want to have the user interface polished and complete so that this looks like a professional product that I can show off to, my friends and potential employers. And then by April 28th, I hope to have completed the project and am ready for my final presentation. So how is this app going to work? By the end of the semester, I want people to be able to download it from the App Store so that they can try it on their phone for themselves. On the main screen, when you open the application, you will be able to load into a view that will have listed the instantaneous rate of charge as well as several other variables like the temperature and the battery level and that sort of thing. Off the main page will be an options menu that will allow users to customize the app. So one example would be allowing them to choose Fahrenheit or Celsius for the temperature, and another example might be that they would be able to change the colors or the theme of the app. On the bottom of the main page, there will be a button so that users can save information for a given table or for a given cable, and then next to that button will be another button that will allow users to compare a cable to a saved cable, just so that they can try and see the differences between the cables that they're using. Other features that I plan on including are a warning message for battery failures. So it'll message the user if the state of the battery is in failure. And then I want another feature to message the user if their device isn't compatible. So if it's using an older version of Android. So what is my progress so far? In its current state, I have an app that will give battery level, temperature, current, and a few other features. And also, as I said before, I've tested out my application on a couple phones, and I plan to make progress by testing it on even more phones until I have a more finished product. Lastly, I've made a table below that shows an example of how some cables and power bricks, how some combinations have resulted. On the left side, I have 4 cables as well as the base discharge of my phone. They are a very flimsy cable that I just had lying in a bin. I have a nicer braided cable. I have a cable for an external hard drive, which is kind of a higher gauge. And then I have a cable that came with my phone. It's the manufacturer's recommended cable. One thing to note about these is that they're all different lengths. So generally, the shorter length, the better the charging rate has been, at least in my experience. And then on the top is 2 different power bricks that I've used. I use my manufacturer's power brick, and then I used the power brick that comes with the Apple iPhone. And they are at different amperages, so we should see different values in the table below. So as you look down the table, you can see that sometimes you bottleneck on the cable, and then sometimes you bottleneck on the power brick. Obviously, it won't be easy for the user to tell which one they're bottlenecking on, but after you compare a couple different combinations of cables, you can start to get a better picture of what the bottleneck is. It's important to note that I did these tests on my phone, and I tried to keep the same environment going as a constant the whole time. So I had airplane mode on, and the screen's brightness was as low as possible, just to make sure that the tests were as accurate as they could be. But in the future, I'm going to try to see if I can run the tests with the screen off so that I can get more accurate results, just to make sure that, there's no possible thing getting in the way of the reading of the power. All right, thanks guys very much for watching. I will see you all in class.